Good afternoon, everybody. Welcome back to lecture number 27. Today we have a very important lecture talking about so keep in mind we have revision 7. We have what? Revision 9. Revision 9, okay? We have revision 9 talking about revision 9 talking about last time we talked briefly about the theoretical. The revision 9 is only adjusted some material, not major. Last time we talked about the IGs for a wind turbine, and I explained to you that we have a gearbox and we have an induction generator. However, this is not everything. We tend to have the gearbox and the squirrel cage induction. Squirrel cage is self-excited. We connect it to an AC to AC converter. It converts the frequency from whatever the one that the speed generated to the 60 Hertz. And we put capacitor banks to inject VARs in the system. Because renewable energy or induction generators do not have what we call the build-up flux. The reactive power, as you can see here, for example, if you include the current capacitor and intersect it with the magnetization curve, you can have the build-up flux. So that's the idea, to add build-up flux in the system. And build-up flux has to do with the reactive power. So here if you have the reactive power, if you look at the other example here, the reactive power is calculated using what equation? V squared 1 over Xm plus this equation, which is the current I2, which is a function of the slip. So if the speed changes, reactive power changes. And for a generator, you cannot have a generator with whatever reactive power, because when you do the power flow problem for the grid, you really need to have capacitor banks to ensure enough reactive power injected, reactive power absorbed from the electric utility or injected into the grid. Injected where? Into the grid. So this was last lecture in a nutshell. Self-excited capacitor banks use the stator, or you can use the rotor side. This is only for the wound rotor, so maybe you can expect a question. You have a squirrel cage induction generator. Can you use DFIG? Yes. No. Squirrel cage you cannot. It's only wound rotor. Okay. And the converters here are cheaper. Why? Because they deal with smaller power. Also, we did before example 9. Where we had a negative slip for the induction generator. This was for the regenerative braking, and we calculated the current that it generates using the power equation. It was 10.5 amp. Then we calculated the power delivered to the supply, which is the power converted minus the losses, I square R1 plus R2 prime. Let's talk today about, so we're done with regenerative braking, and clearly, wind turbine operates in regenerative mode. No, wind turbines are regenerative brakers. They're still braking, because braking, the winds are pushing the blades, but the flux is braking them, controlling them to generate electricity. The other type is called dynamic braking. What is a dynamic braking? Dynamic braking, take for example, let's read the slides a little bit. The braking resistance method is possible. However, adding stationary field leads to fast stopping. No, not this. It's this one. Dynamic braking concept, my bad. When a motor rotates, kinetic energy is there. you disconnect it from the supply, what happens?
So it's there.
It's gonna spin, speed will slow down until it stops. So can you stop this suddenly?
كذا برجع بوقف الموتور.
Electric motor. كيف توقف an electric motor?
Plugging.
Yeah, this is one thing. But let's start with a simpler approach. Can you replace your mechanical load? Now, it was initially connected motor to the supply. Can you, instead of connecting to the source, can you connect it to a resistor and you dissipate this as a heat in the resistor? That's one option. So in this scheme of braking, it is initially connected between point A and A. So you have IA, which is what? A motor. You connect it to a resistor and the flow of current would be reversed to be dissipated in the resistor. So now you're making the slow down process faster. You dissipate it as a form of heat or light or heat or whatever, okay? When a motor rotates, kinetic energy is stored. If the motor supply is disconnected, the stored kinetic energy in the motor mass is dissipated in the rotation of the motor until discharging its energy and the motor stops through the resistor. The faster the discharge, we can go to zero faster. In dynamic braking, energy stored in the motor can be converted to electrical from supply using a resistor as shown here. So this mechanical movement of the motor while it stops down can go to electric again. The value of added resistance can be calculated using this equation. It's I square R. What is I square R? Power. Power times time is what? Energy. So you can calculate the time that you want to brake. You can calculate the energy and you can design your value of resistance. So if I tell you in the test you have 100 joules, you want to have a current no more than 5 amps, what's the value of the, in 0.5 seconds, what's the value of the resistance? Clear? So IB is the braking current, RB is the braking resistor, TB is the time interval. Here it's capital T, or you can use a small t, that's a typo. You use a small t. Okay? The smaller the resistor, if you have a smaller value of resistor, you're going to have higher value of current. But the current is I square R, so this leads to faster response. Did you get it? Again, smaller value of the resistor would lead to higher value of the current, but this is in I square, faster than the linear one, so the time will be small. Get it? The current direction is reversed, so now we are in the direction mode. But this is old school. But now we have 460.
0.60.
What is the power code? 461?
460.
460, yes. So now we have 460. Imagine in the 460, let's say, so the motor is the 3-phase, right?
Mm-hmm.
Let's say I connect A and C to the neutral, B to N. Basically, I make the A and C in parallel with each other, and B in series with them, and I take my neutral point here. The braking resistance method is possible. Adding a stationary field leads to fast stopping. So adding a field is better than a resistance. How this adding a field for braking is possible? By generating a DC supply on the terminals of the 3-phase, a fixed flux will cause a fast stopping for the machine, provided that the DC current should not increase 3 times rated of the motor rated current to avoid damaging the motor windings. So the idea of this type of braking, you missed the first part, is you just add a resistor. If you add a resistor, you have I square R losses, and you dissipate it. But this is waste of energy, waste of time. A smarter approach is we generate DC supply on the terminal. We apply DC volt in, let's say, A and C windings. We put them in parallel and we make it in series with B. This is one configuration. A DC supply can be applied to the motor terminals using what we call the 6-step inverter. Did you study the 6-step inverter? Okay, this is a voltage source inverter. This is a 6-step inverter. And you apply the switches to make the connection. For example, if S1 is on, S5 is on, the DC is applied to phase A, phase C,
156, I think.
and then 6 would make the B connected to the negative.
Yes.
So B is connected to the negative. So you take your DC source, you make switches S1, S6, S5. If you make S1 on, S5 on, you connect the A and the C to the positive. If you make S6 on, you connect the B to the negative. That's why we have this connection. So you apply a DC using pulses. If you want to change, you can have another configuration. Maybe you can have 1, 3, 2, etc. But how does this work? How does this work? Do you remember when we talked about induction machine in general, we said we have the stator and we have the rotor. صح? What we said is you apply DC, you apply AC, then you're gonna have a rotating RMF. صح? So the rotating RMF, it rotates sometimes the north and south here, after some time the north and south here, after some time the north and south is here. The squirrel cage rotor would align and rotate until the slip is satisfied, but they would have, because of their rotation, the current bars, the bars or the wound rotor would have FR current or IR that would generate also magnetic field that would chase the N and the S and follow it. Clear? Now if you apply a DC field, it will be, for example, the N here and the S, I'm going to call it DC, I'm going to call it DC, so it will be fixed. So the moment the rotor magnetic field rotates, this is north, this is south, حق الروtor, the moment it sees this DC south, it will lock معه, because this is huge. Clear?
Yes.
So this is what we call the field braking.
توقف على طول بعدين.
It will stop if it didn't pass, it will reduce its momentum. Maybe in the second time it will stop. It's very easy concept, but you need VSI, voltage source inverter, to do it using the switching. So this is how we connect it. In the rotor circuit we have RB and rotor windings. The rotor would have a rotating magnetic field that will lock with the magnetic field generated by the DC. This is on the stator, this is what? On the rotor. This is very important braking concept, okay?
يعني قاعد تضيف بس إنه ما يستوعب ما يمكن في الستيت.
A induction machine, you connect using the inverter على 3-phase windings, you connect a DC component. This DC would have a DC field. This DC field, the moment the rotor hits it, it will lock with it. Because it locks with it, it will break down. It's very easy.
بس الانفرتر ده في AC ما في DC.
No, that's not the inverter. This is a switch. If this is on, You apply DC.
اه
If this switch is on, you connect it to whatever A.
ايوه بس احنا قاعدين نحول الدي سي للاي سي هذا اللي قبل في الانفرتر we convert DC to AC.
No, this is yeah. An inverter is depending on what you connect على ال A will be with C.
طيب هذا AC قاعد اطلع AC.
But you are connecting to 3 different cables.
اوكي
If you connect it, get it?
لسه
If you connect A هنا في A في winding صح؟
حلو.
حقت الفيز A. If you connect this to a DC supply, what happens? You just connect the switch على الها. A DC will be
اي
C.
صح صح عشان اوكي اوكي
No, you're talking about another application. You're talking about
هو
chopping the signal.
لا هذا هو AC بس انه اللي بيطلع AC بس
It is
يكون AC ليفلز معينه
6 steps.
2 ليفلز
Yes, 6 steps.
او 6 ليفلز
This 6 levels.
لا وصلت خلاص
Like 6 levels. But ال A windings would see a DC. ال B windings would be see a negative. So you have 6 levels. Okay? Clear?
انا فهمت كيف
في ال BSI you don't use ال 156. You fire every time different sequence. You fire 9 sequence. But here you only fire 1 sequence. So you get 2 levels.
ايوه
If you have another sequence, you have another 2 levels. هنا يصير ال AC. فهمت؟
مالتي ليفل انفرتر
Yeah, it is a multi-level inverter, but you're sending only one pulse,
يس
one command, 1 0 1 0 1 2 1 0
1 5
0
1 2 هو حسب
whatever 1 1 1 0 0 0. If you change the sequence هنا يطلع لك ال AC حق الانفرتر. So if the rotor is wound type, a resistance in the rotor circuit will help. You can also merge both of them. You can have resistor and field في الwound. This will be even faster with minimal losses. So if the rotor is wound type, a resistance in the rotor circuit will help to dissipate. So you can merge both of them. You can merge both of them. There was a question before about what's the difference between DC and VB. The difference between DC and VB is the following. For DC we have 200 volts. You apply it to 6-step inverter and then you get a VB which is smaller based on the duty cycle. So let's solve this example. Induction motor is driven by a 6-step converter similar to that shown in the figure. The voltage DC is 200, so DC is 200. Normal full load torque operation, the motor current is 25, so you are capped with what? 75. So IB is 75. It's 3 times I8. If you solve this equation and plug R of 0.5, you get VB of 56. Now, using the power electronics, the VSI voltage source inverter is driven by frequency with modulated signal. The relationship between the duty cycle and VDC and VB is D equal 1.5 times VB over VDC all square. So in this example, 56 over 200 all square times 1.5 is 0.119. So the VSI has to give a duty cycle of 0.119 to achieve dynamic braking for this example. So how many types of braking we had?
3
We had 3 different types of braking. The first one is regenerative braking. We already covered that. Regenerative braking is for active loads. Dynamic braking, how many types? 2, resistor and field. Counter current braking is the third type which we will cover now. Okay? For the counter current braking, when 2 phases are reversed, which is the plugging mode, the machine will, phase sequence will be reversed, and hence the machine will rotate in the opposite direction. Here we have the first quadrant, speed is positive, the load torque is negative, motor torque is positive, clockwise, okay? If you do the phase sequence, the load torque will be reversed and the motor torque will be negative. The speed now will be negative. So negative speed, negative torque, positive speed, positive torque. By reversing the phase sequence, the electromechanical torque will be reversed and the motor speed will be changed as well. By sensing the motor speed, here is the countercurrent argument. By sensing the motor speed, the supply can be disconnected when the motor speed became 0 and before of reverse motion occurs. How this happen? The idea behind it is once you apply a phase sequence, you will disconnect the supply only when you reach a 0 speed. And here is how it occurs. Firstly, the motor was working at point 1 in motoring mode for ABC sequence characteristics. This is the capability curve. So let's say we operate here at point 1. Okay? Point 1 you have ABC sequence. Do the ACB now. What is going to happen? We go to the plugging mode. صح? But can you jump directly? Can you change the speed suddenly? No. We zoom in. You cannot change the speed suddenly. So now we jump from the ABC curve to the ACB curve, which is the plugging mode. So our goal is to go to the plugging mode, which is here. Plugging mode, we explained before, it was speed and torque. So plugging mode was here, but now we're reversing everything, so plugging mode will be here because we have torque, speed. So you start at this region and then you keep applying the ACB voltage. You have a speed sensor until you reach speed 0. What is your goal? To reach speed negative something or speed 0?
Speed 0.
And then you remove this. Then it will stop. It's very smart. Get it? So you're operating at the plugging mode, but you have to have a speed sensor. What is the purpose of the speed sensor? To catch when you reach 0 speed. This is very important. Counter current is very important. Since the phase sequence is changed, the machine capability curve will be changed to the ACB1. The transient transformation is always made at the same speed. This is transient transformation. From one curve to another, we cannot jump the speed. We are not lights. You have to take, it's mechanical. It has to take time. So the machine operating point will go to 2. To catch the load torque, the machine needs to move to point 4, therefore the speed will be reduced moving from point 2 to 4. However, because our goal is to stop the motor, is we can disconnect at point number 3 when the speed becomes 0, just disconnect the supply. خلاص speed 0 ما في inertia, ما في movement. It has to be accurate. If the motor is not stopped at point 3, there are 2 possibilities. If the load is active torque, what is active torque? It means it can reverse its load torque from counterclockwise to clockwise, similar to the car going up to the hill and down to the hill. The machine will continue moving to point 4 and working in what we call reversed motor mode or quadrant 3. If the load is passive torque, non-reversible, the torque of the load has only one direction like the constant torque, the machine will continue to point 6 and working in the generating mode. This is very important. For active load, we can generate using regenerative braking. Basically, we exceed the supply, the speed. For non-active load, we have to use counter current and go to quadrant 4 into the generating mode. So we have, if you have an active load, you just go here to generate. How to generate electricity from non-active load? Constant torque. Load is always constant, fixed. You have to go through counter current and then go back to quadrant 4. If you have an active load, car going up and down, you can go directly here. Just increase the speed of the slip. This is side information. If the load is passive torque, non-reversible, the machine will continue to 0.6 and working in the generating mode. Because the torque is non-reversible. It cannot have negative torque. So you have to go through this cycle to make the torque here, to reach this curve. Okay? So this is very important. Please do not forget to solve the additional problems in the drive.
خلصنا الشابتر. خلصنا الشابتر.
And this is, okay, it will open for you. We need to sign in. We'll show you the problem. And this is the end of module 3. So let's have a talk about the major exam. How many minutes? Still working? So some of you الإجازة متى نرجع؟
واحد.
واحد.
أنا أول أبريل.
So to be honest with you, I think April 5 is not a good day for the majors.
الحمد لله يا رب.
We have to make it late. So tell the group, April 5 will not have enough material.
عطنا.
So I'll give you
busy.
discuss on the vacation. And after the vacation we'll decide. It will be toward the end of April. Okay?
Week
The end of April.
Yes.
أسبوع.
Yeah, I don't know. We can decide, but I'm not gonna make it April 5. We did not finish enough material.
يعني متى المينيموم متى الماكسيموم؟
I would say let's target these 2 weeks.
خلينا نقول على
Either week of 12 or week of 19. Choose. Okay?
نشوف المناسبة.
Put it in the group now.
صار 19 التخرج يعني بس عندنا 12
Let's ومتى graduation date?
22.
22?
21
What's the problem if we make it 21?
لا في 21 حق مرات بالشهر
It's okay. 20.
في بروفا
طيب ايش دخل الجراديويشن بال
So maybe this week is better.
ما ادري هو
This week is better. Okay?
هو من جد ايش دخل الجراديويشن بالدكتوراه؟
I'll tell you later. Okay?
طيب خليه يكفي 15 طيب.
Oh, my dream is to have it here. This is my dream.
طب طفل كام ولا وش هو؟
26. No, they have to watch it. 26. But anyway, April 5 is not doable.
26.
No. April 5 is not doable. Here we have the
دكتور ايش معناته
graduation.
الويكند؟
Here we have the graduation. Here I cannot have it. It's too late. So most probably it's going to be in this week. Okay? Or maybe Sunday before graduation. I think that might be a good date. Sunday.
مع دكتور
What?
حطها في ويكند.
Weekend is difficult.
ليه؟
If they agree, we can do it in a week. If they agree. Or Saturday in the evening or something. Saturday evening before.
weekend.
Okay? That's one thing about the major. So we still need to cover the DC machine. The other thing is there is problems, you have to solve them, okay? We don't have time to solve them, I wish I have time. But the problem, there's 4 problems for induction. The second 2 are controlled, solve them, okay? Similar to what we did. What else do we have?
Project.
The project. So I think about the project, I will release it, I'll make it simple. But the project has presentation report. We call it the 5 minute presentation, the 5-page report, and it will be
solo ولا team.
no, everyone is. I don't. I'm not gonna make it. You want teams?
ما ادري. حسب البروجكت واللي تعطينا اياه نقرر.
Okay, we can make it teams. Let's make it teams of 2. So I have 10. You choose to make a simulation. Now, if you make a simulation, I will probably give you higher grade, naturally, because it's difficult. So if you want to learn, do the simulation. Don't worry about it not working. Okay? If you don't want to learn, and you want to take the shortcut, I'm going to give you a simple design example. Simple design, you solve it. You do the 5-minute presentation, you do the 5-page report.
خلاص خلها سولو إذا فوزوا.
What?
خلها سولو.
No, I'm not gonna make it solo. خلاص, we already said this too.
I did say.
خلاص, no, I'm not gonna change it. Teams, I don't want to grade 20 reports, I'll grade 10. So every 2 students, you agree, and then you submit. Okay? The bonus, the PWM, and the CV, is keep sending me your things. For the CV, you have to meet me, call me on Teams, or come to my office to give you the feedback. I'm not gonna edit your CV. For the PWM, the bonus will be added to your overall classwork, okay? And we will start after the vacation. We might need additional lectures, okay? تخريج هنا في المنهج.
كم باقي؟
We still have a lot. We still have the DC machine, we have special types machine, we have variable speed drives. 3 modules.
نبلع شوي.
No, but those modules are smaller. And the most important one is the induction machine. Okay? The induction machine is the most important one. We finished induction.
Sure.
So the recording, I'll try to merge the 2 videos. If not, I'll upload 2 videos. Try to. Do you know how to merge 2 videos? On YouTube?
تسوي برنامج اسمه تدي فيديوهات.
We'll see how. I think there is a way to add the 2 videos. Fake quiz. We'll have a fake quiz after the vacation. A week after the vacation. What date you want the quiz?
هذا الجواب.
It's a Tuesday, okay? No. Okay. It will cover the material after the quiz.
What?
So it will cover.
أول أسبوع تتفرغ الإجازة.
Yeah, well, Tuesday. It's fake quiz. Fake quiz will cover. We'll cover the break. Anything has to do with regenerative braking and moving forward. Okay? Have to prepare for the test. Any fake quiz. Okay?
الميجر ماتيريال الميجر تكون
All induction machine
موديل 3.
plus whatever we finish in module 4.
اوكي.
Okay?
ان شاء الله.
Any objection? And you have to solve the exams. I uploaded the solutions. We will have homework released this vacation.
شعبي صار.
Huh?
ليش؟
Because it's 462. Time is up, but I wanted to show you the problems and which one I think looks better. This is practice, okay? So this is our favorite table. This is 360. This one is also 360. Here they talk about one is using synchronous speed, one is using omega. You can see one is 84 Newton, one is 82. It doesn't matter. But the last 2 is the speed control. So solve this example 5.9 and 5.30. Okay? These are 2 practice problems. Solve them. If you have any question, let me know. The solution is posted. Okay? بالتوفيق.